Once upon a time, in the vast and orderly kingdom of mathematics, the real numbers reigned supreme, from the simple act of counting apples to the majestic motion of the planets. Real numbers did it all, positive and negative, whole and fractional. They were the dependable builders of logic, geometry, and science. But then a curious whisper began to stir. What number could satisfy this strange equation? X squared plus 1 equals 0. A number whose square is -1? This question was dangerous. To the ancient Greeks, it was a riddle that made no sense. They believed numbers were meant to count real things, lengths, weights, quantities. But this was a mathematical ghost. For centuries, the idea was shunned. The square root of -1? Pfft, nonsense, they said, an impossibility. Even the great Al-Khwarizmi, father of algebra, avoided it like a curse. But ideas, especially strange ones, have a way of lingering. Fast forward to the 1500s, Italy, the Renaissance, a time of art, discovery, and equations. Enter Cardano, a brilliant but eccentric mathematician. He was solving cubic equations, the kind no one else dared to try, and suddenly, a ghost appeared in his calculations. Squared root of -1. He didn't understand it, but he didn't throw it away. He wrote it down, passed it on. Then came Bombelli, who did something remarkable. He said, "What if we just work with it?" He began manipulating these strange numbers, multiplying them, squaring them, combining them, as if they were real. He didn't know it yet, but he was opening a door. In the 1600s, Descartes gave them a name, imaginary numbers, not out of admiration, but to mock them. These numbers, he said, exist only in the imagination. But little did he know, the greatest minds were about to prove him wrong. Euler came along and embraced the mystery. He gave it a name. Iota equals to square root of -1. Si on a modern phi, he saw its power, he saw the hidden symmetry. Then came Gauss, the quiet genius, who declared, "Imaginary numbers are just as real as the real ones." He showed how these numbers could be visualized on a plane, the complex plane. Suddenly, numbers weren't just points on a line. They had direction. They had dimension. They could rotate, spiral, and dance. And then, Hamilton, walking by a bridge in Dublin, had a flash of brilliance. He carved his discovery into the stone. I square equal to j, square equal to k, square equal to -1. He had discovered quaternions, unlocking a new universe of four-dimensional numbers. What began as a forbidden thought, a mere mathematical ghost, had become essential. Today, imaginary numbers power our world. They are the foundation of quantum mechanics, electrical engineering, signal processing, fractals and chaos theory, Fourier analysis, and the digital world. Even the heartbeat of the universe, the Schrödinger equation, pulses with the rhythm of iota. So next time you hear someone say, "Imaginary numbers aren't real," smile and remember, the most imaginative idea in mathematics turned out to be the most real of all. And that is the story of the imaginary, a number born in shadows, now shining at the very center of science.